bejesus out of you. Bang, bang, bang. That's still not as bad as my ex-wife's Annabelle doll. Did I ever tell y'all about that? Oh my gosh, that scared the crap out of me. All right, we should be recording, and let me get the whiteboard up, and we'll go from there. We'll go over a couple more area between two curves, and then move into volumes, shells, discs, washers, all that good stuff. Just a kind of a review again. Now I passed out. Let's see, can I do this? There's no way. Yeah, there is. Hold on a second. I'll give y'all a problem. I'm going to send this to them because they'll be too lazy to print it out too. So I'll send it to them through the, I'll send them a picture of it. That was what I had for breakfast 2 days ago. Didn't get anything this morning because of the stupid machine downstairs.
Didn't we serve breakfast together? We used to, the first semester I was here, they had like a little breakfast bar.
I know.
That was great.
All right, let's do this one. I don't know if we did this one or not yesterday or not, whenever y'all were here last. Let's go with y is equal to the square root of x plus 2. Y is equal to the square root of x plus 2. And x is equal to 2. X is equal to 2, and x is equal to 0. And y is equal to 1 plus x, 1 over x plus 1. Or you can call this f of x, and call this g of x if you want to. Now, of course, the first thing you want to do is what? Besides finding the intersection points, what do you want to do first? Draw a what? Draw a picture, exactly. Now, while y'all are doing that, I'm going to see if I can get this to our fine folk on Skype. Let's see if I can do this. A picture. I guess I could send it to myself. The things I do for y'all. Okay, I'm going to send this to myself. Then I'm going to pull it in.
Unless you can find it on the computer and tell them to just screenshot.
That would require them to do something. And y'all all know that students are what? Lazy. I mean, I could give y'all worksheets, and do y'all go home and print them out? Hell to the no. Yeah, no, so I have to do this. Okay, attach. I'm going to try this. I don't know if it's going to work or not, y'all, but I'm trying it for y'all at home. Send. I'm going to freeze this. When I freeze the screen, do y'all see the frozen screen at home on Skype? Okay. I need to do that when I go to my Facebook while y'all are working. No, I'm just kidding. All right. Well, I can pull it in as a picture. Can I? Yeah, I can do that. I'm trying to learn how to do some things here, so y'all just bear with me. Okay. We'll go ahead and do the roll too. email. Save this picture. Save as pictures. Now, I can pull it up also, of course. There. I can do that. I'm talking to myself, y'all, just ignore me. All right, Ahmed. Oh, you must have walked in late. Anderson's here. Bradshaw is here. Edwards. Grant. She is sick. Hutt is here. Khalil is here. Nabay is here. Patel is here. Peer is here. She's on Jigger. Scobie is here. Sheik is here. Silver is here. Thompson is here. Tucker is here. Wisenhunt is here. Williams. Okay, so everybody's here today. Wow, it's a miracle. Okay, now back to me pulling this up. What I'll do is I'll do another screen and pull this in as a picture. No, there it is. Paste, insert image. There it is. Okay, y'all see that? Skype people?
Yeah.
You may have to take a picture and rotate it. I thought I had it done the right way, but evidently something happened. So that's the handout that I handed out today. Give y'all a minute or two to take a picture of it or do a. Can you still do a print screen? Not print screen, but can you still do a shot off the screen now? Yeah, I know you used to, but just do whatever y'all need to do. Let me try that. I'm trying something else now. Go to Skype and do what now? Well, I have to find it. What I do with it after I find it. Right here. Here's the picture. Yeah. Yeah, but where do I drag it?
To the message.
To right here? But I can't do it right from there. Right here?
Yeah.
Okay, let me move this over a little bit. Just drop it right there.
Yeah.
All right, see if y'all see that. Okay, somebody speak.
Yeah, it showed up.
Okay, so now y'all both, thank you. How did you know that? Oh, okay. Well, thanks. Skype or Skype for Business. Skype? Okay. Well, I'm glad you know that. Now I can do that. Thank you. It'll give me something else to play with. This is how I get my training because Tri-County Tech doesn't offer training. So, at Tri-County Tech, you got to be hard. You got to find out your own way. All right. So let's pull that up. We've got a graph that looks like, I don't know, it's got a, take your handy dandy, white, x is equal to 0 is this way, x is equal to 2, 1, 2 is this way, and then we got square root of x plus 2. Well, the plus 2 means a horizontal shift of 2 to the what? Left. So 1, 2. I'm just sketching this because, I don't know, something like that. And then that's that, that's that, that's that. And then 1 over x be some kind of volcano, half a volcano, right? But the plus 1, that's the horizontal shift to the left. So that's going to be over here. So it's going to be something, y'all help me out here. It's going to be something like this, maybe. I don't know. This is the area right here that they want. That's supposed to be above like that. There we go. Just use your imagination. Use your calculator. Is that something like what we're talking about? All right, so where are we going? From 0 to what? From 0 to 2. Now, you got to subtract. This is the x plus 2, so subtract the x plus 2 minus the what? 1 over x plus 1. So get to work. Now that I've shown you what to do, show you what it looks like. And you probably are not going to be able to subtract the 2, so you're just going to have to use your rules of integration and integrate. Now, since it is a minus symbol or a plus symbol, whichever the case may be, you can break it up into what? Instead of 1, you can break it up into what? 2. So you've got the integral from 0 to 2, or the antiderivative from 0 to 2 of the square root of x plus 2 minus 1 over x plus 1. Now you can bring that x plus 1 up and make it x plus 1 to the negative 1 and have this as x plus 2 to the 1/2, but is that going to do you any good? No, Hubert. Why? Because they're different bases. That's right, class. So it's not going to help you to do that. So you might as well just break it up into what? Just break it up into 2 intervals. No faulting in class. So I'm going to change this to antiderivative from 0 to 2 of x plus 2 to the what? 1/2 dx. And then minus x plus 1 to the negative 1 dx, antiderivative from 0 to 2. Now, u is equal to x plus 2, then what is du? 1 what? dx. So we have a 1 dx here. So this is u du. So antiderivative from 0 to 2 of u du. So do the power rule there. And here, u is equal to x, du is equal to 1 dx. So this is u to the negative 1 du from 0 to 2. So that's going to be 0 to 2, u squared over what? 2 du. I'm sorry, I'm not going to do du. Minus 0 to 2, u to the what? What's negative 1 plus 1? 0 over what? 0. So what is this part going to do? It's going to cancel basically because you can't have it because that's 1 over 0, which is undefined. So that's going to go out and it's going to leave you with just this. What 1/2?
X plus 2 doesn't have
Did I not? Oh, I'm sorry. I messed up. That's supposed to be 1/2. I didn't put it. Thank you. Okay, 1/2 plus 1 is what? 3/2? Thank you. You know you're supposed to wait till the end of the problem when I finish, and that's when you're supposed to say something. Oh yeah, right. You're not one of my students. Yeah, that's what my students do. They wait till I get through, and then they say, and then the one up front, they say, yeah, something's wrong. And then Bubba in the back that has no idea what planet he's on, he goes, yeah, man, you're wrong. And then the whole class goes, yeah, I saw that, yeah. And then by then so thank you, Mr. Whistlehunt, for being considerate. Not like my class. Okay, so does that look better? We already took the interval, so that's evaluated at 0 and 2. All right, finish it out. Oh, I wish I had a Sprite right now.
Wasn't there something that
Toothpaste, really. Ugh. Wasn't there something
that like youth negative 1 goes to water?
Yeah, I'm sorry, because I didn't write. 1 over U, thank you. I ain't got anything to drink, that's what it is. Thank you. This is 1 over U. This is 1 over U du, which is equal to the natural log of absolute value of U. So that would be the natural log of absolute value of U evaluated at 0 and 2. And U is what? X. There, how's that look? Now do both of those. How we doing at home? Everybody good?
Yep.
I got
We're
one
good.
up, so that means everybody's good. Nobody's got any questions. Okay. Y'all are impressed, aren't you?
Training.
You dang right. That TC training, man. Where they throw you out in the water and you either what? Sink or what? Swim. That's Tri-County Tech's philosophy. The School of Technology. Give you a system, give you a projector and a board, and you figure out how to use it. So, that U is x plus 2, so that's going to be x plus 2 to the 3/2 multiplied by what? 2/3, evaluated at 0 and 2, minus, and you can do the natural log of x, evaluated at 0 and 2. Now, you can do this all at one time, and you can say 2/3 times x plus 2 to the 3/2 minus the natural log of the absolute value of x evaluated at 0 and 2, and do it that way if you want to. Either way, you've got to do 0 and 2, so I'm going to do it this way so that I can remember what I'm doing. Okay. So that's going to be 2/3 times 2 plus 2 to the what? 3/2 minus natural log of 2 brackets minus 2/3 0 plus 2 to the 3/2 minus natural log of 0. And of course, what's the natural log of 0? So that's going to give us 2/3, 4 to the 3 halves, minus natural log of 2, minus 2/3, 2 to the 3 halves, minus 1. Now 3 halves, that's exponent over index, so that's the square root of 4 to the 3rd power, 2/3 times the square root of 4 to the 3rd power, minus natural log of 2, which I have no idea what that is. Yes, come on, man. Oh, thank you. What is that? Hot chocolate?
The
Thank
big
you.
machine, I thought we'll have cash today, so I said, maybe I can get it from it.
Yeah, somebody ordered the fruit juice, and it's still stuck up in the top left-hand corner. So the square root of 2 to the 3rd power minus 1. I'm trying to do this without a calculator. Of course, I'm going to have to wait until that gets down to at least 90 degrees, because it's probably 115 degrees. But thank you. Okay, so what's the square root of 4? And 2 to the 3rd power is 8, Hubert. That's right. 8 times 2 is, so that's 16/3. Somebody check my math. Minus, well, the square root of 2, that ain't going to work. But I can do the square root of 4, which is 2 times the square root of 2. Somebody check me there. So that's going to be 2 times 2, square root of 2 over 4 minus 1. 16 divided by 3 is not 8, although sometimes I try to say that. But that would be 5 1/3, 5.33. Minus natural log of 2, which I have no idea what that is. 2 times 2 is what? 4. The 4 cancels. So that's going to be 1.41 minus 1 is 0.41. I'll get there in just a second. All right, what's the natural log of 2? Calculator, drill team. Huh? I don't know. That's calculator, drill team. Natural log of 2 will be a different number. Because natural log is what? I'm sorry, what?
0.693.
0.69.7. 5.3 minus 0.7 minus 0.41, and that's going to give me $5.30 minus 70 cents will give me what? $4.60. Somebody help me out. $4.60 minus 40 cents is $4.20. So around 4.2 should be your answer. What'd y'all get? You get exactly 4.2?
4.19.
Oh, okay. Now, that's the area that we had a while ago. Now, somebody asked where I get the 4 from. Hell, I don't know. I know what I did. I was multiplying 2 times 2 in my head. I'm sorry. That's supposed to be a 3. Is that the 4 you were asking about? Yeah, I just decided to change the problem. Sometimes when teachers are doing stuff in their head, they write down what you're doing in their head. I was doing that 2 times 2 in my head. All right, so that 3 transfers over here. So that's going to be 4/3, which is what? 1.33, right? So that's 1.33 times 1.4. Is that right? Okay. 1.8 minus 1 is 0.8. So this is going to change to a 0.8. And this changes to a 0.8. And I done forgot what I was taking away. So what's come out to be? Not minus.
5.3 minus 0.7.
Okay, 5.3 minus 0.7 I said that was 4.6.
Yeah, and then minus
4.6 would be 3.8. Sorry about that. See if that works out. Do your math in your calculator and see if you get around 3.8. Yeah, you should. I think you do. Well, remember I told you it canceled out. So you can, I mean, natural log of 0, you should cancel. I thought natural log of 0 was 1. You sure it's not? It comes up as what? Let me see what problem this is. This is number 2, of course. Let's see what they did. I think I got a solutions manual here.
so natural log of 1 is 0.
Okay, that's the one I was thinking. Thanks, Mr. Huth. 6.1. Always telling all my students to screw me up. 6.1, although I do a pretty good job myself with 3 turning into 4. This is number 2. They got natural log of 1. How did they get the natural log of 1? Oh, I know how. Because u is equal to x plus 1. Don't say it. Don't you dare say it. And then Bubba.
Yeah, man. I thought that's good.
X plus 1.
I swear I wanted to say something, but I
forgot where I was. Right here. You see this right here?
Yeah.
I said u is equal to x. U is not equal to x. U is equal to what? So y'all need to plug that back in. My bad. Which would be the natural log of what? 1 here, and the natural log of 2. So just hold up. Let me find it. So here we go, over here. So this would be, instead of, I got this right. Let's see. Yeah, natural log of 1 is 0, right here. Doesn't this turn 0? Right there. And then this turns to 0. So 2 times this right here becomes 0.8, or let's see, 2 times 2 is 4. 4 divided by 3, what I say is 1.3 or 1.33, right? 1.33 times square root of 2. Somebody do that for me. 1.33 times square root of 2. 1.8. So that's 1.8 right here. Oh, hell, let's just do it over. Let's just do it over. My mistake. Y'all should have seen that at home. But you were waiting till the end of the problem, right?
what do you say? You told us.
Okay, so let's just do it over. Let's just take this out right here too. Okay. So we've got, this is x plus 1 right here. So 2/3 times 2 plus 2 to the 3/2 minus natural log of 2 plus 1, which is natural log of 3, right? Natural log of 3, brackets, minus 2/3 times 2, or 2/3 times 2 to the 3/2 minus the natural log of 1. Y'all check me now. And that's going to be 2/3 times 4 to the 3/2 minus, somebody give me natural log of 3 in your calculator. Just give me it to the 10th. minus 2/3 times 2 to the 3 halves. I'll fix that in just a minute. And the natural log of 1 is what? 0. And then 4 to the 3 halves means the square root of 4, which means the square root of 2 is 2 to the 3rd power is 8. 8 times 2, so we still get 16/3 here, right? Minus 1.1 minus 2 over 2, that cancels out, no, 2 over 3, that changed the problem again. So that's going to be the square root of 2 to the 3rd power, which is the square root of 8, which is 4 times, square root of 4 to 2 times square root of 2. So that's going to be 2 times square root of 2 times 2 over 3. Y'all check me there.
How did you do that?
Well, the square root of 2 to the 3rd power is the square root of 8, right? And the square root of 8 is the square root of 4 times the square root of 2. And the square root of 4 is what? 2. So you get 2 times 2 times square root of 2. I'll do that in just a minute for you. 0.
You're doing 2 to the 3rd power of the square root.
Right, yeah. It's right here. That's exponent over what? Exponent over index. So that's the square root of 2 to the 3rd power, which is the square root of 8, which is equal to square root of 4 times the square root of 2, and the square root of 4 is what? And then you take that and put it down there, and there's already a 2 there. So that's going to be 16 over 3. Y'all said that's 3.3, right? 3.33? No. 1.33? No. I'm sorry. 3 will go in there. 5.33. 5.3 minus 1.1 minus, this comes out to be 4 over 3, which is 1.33. So that's 1.33. 1.3 times 1.4. And you said this is going to be 4.2.
1.2 minus 1.82.
And that comes out to be what, 3?
2.3.
I thought you said this is 1.2. Okay, 1.82, 1.2, there's no difference. 1.82, which comes out to be what? 2.4 is good enough. Now, we just spent a lot of time on tedious math, right? A lot of books and a lot of calculus teachers don't even want you to do that last part. Okay? And this doesn't matter to me as long as you know how to do it. As long as you don't make up numbers like the teacher does and throw up stuff up there. Mostly, they want you this right here. Or they want something like this. Okay? In other words, they just want the setup. More than likely, if you do a problem in math, in calculus, 90% of the time they're just going to want the setup. Now, sometimes I give you the math problems just so you can refresh yourself on math a little bit. But I'm very, very lenient on your rounding. In other words, if you want to do what I do and just round it to a number and then just do it in your head, then that's fine. Okay, but if you want to take it out in 5 digits for each thing that you get and take it out in 5 digits for the final answer, that's fine too. If you have 5.1246 and Miss Faith has 5, I'm going to count both of them right. See what I'm saying? If I ask you to go that far. And sometimes I ask you to go that far because just to refresh her over the basic math, okay? Let's do one more. And I'm going to pull this one out of the section that don't have the graph. And their answer in the back of their book, they didn't even take it down that far. This is what they got. They got 16/3 minus natural log of 3 minus 4/3 square root of 2. Is that what I got?
Google said the answer is 2.33.
What?
Google said the answer is 2.33.
Google? What do you mean Google?
Like the only thing that Google calculated, we got 2.33.
Now see, that's wrong. They shouldn't do that. because that's not helping the student at all. What did I get?
2.38, that's pretty much.
So she got 2.38, I got 2.4. She got it right. And you said it was 2 point what? Okay. Well, this one don't have it. It has just, see, they didn't even ask you to do the math on this. So let's do, if you got a book, I'm in on page 427, and that's where I would rather you do your homework out of, because the problems they give me to choose from on the thing is not that good. So 5 through 20, that's some good problems to do if you want to do some by hand on page 427. Let's do y is equal to 12 minus x squared, or f of x is equal to 12 minus x squared and g of x is equal to x squared minus 6. Now, is this one bounded, or do you have to find the boundaries? You have to find the boundaries, because I don't give you an x is equal to 5 and x is equal to 0. At least Faith knows that I can't drink coffee, so at least she knows that. That tastes like hot water to me. You ever taste anything that you taste and other people taste it and you taste nothing? And that's what I taste when I drink coffee. Unless I put sugar and milk in it, and then I taste the sugar and milk. I don't taste the coffee. So I don't have a taste bud for coffee. Huh? I'd rather drink dirty water than coffee. Yes. At least I can taste the chocolate. I can taste chocolate, but I can't
Now you
taste
have a
coffee.
little cup, you know, you can put your shot in there.
Yeah, I can take this home and reuse it. Now this is a good shot glass. I can't stand those little shot glasses.
That's like 2 shots.
Yeah. I like the little red Solo cups. You ever seen those?
Oh yeah.
Those are so cute.
We have no house.
I got some that I never open. I just keep them up in case of emergency, kind of like, a fire plane. Keep in case of emergency. I have little red shots for my medicine.
We used to always have eggnog.
I tried eggnog and I just don't like it. I don't like the eggnog with the Southern Comfort.
It's amazing how many calories are in it.
It's all sugar. This is no joke. I can tell you this story. I told my class probably this a long time ago. But one time during hay season, it was real hot, and I came in, and I'd already drank a couple of Gatorades on the tractor. And I don't drink the little bottles. I drink the quarts. And I can down a quart in a heartbeat. And I drank a couple of those while I was on the tractor. And then I came in and I mixed up another big pitcher of Gatorade. And I drank it. And then I ate spaghetti. This is no joke. The next morning I woke up, I felt like I got hit by a train. I had the biggest hangover that a person could have. Yeah. Because what is all that I drank and ate? Sugar. What is alcohol? Sugar. I had an overload of sugar. Oh, buddy, I woke up next morning, I couldn't hardly stand up. I wasn't drunk or anything. My head was hurting. I couldn't open my eyes. Thank God I didn't have an 8 o'clock class that morning, because I wouldn't have went. I have never got a hangover from Gatorade and spaghetti, but I did.
Do you found me?
Yeah. No. I got 10 bales, and I'm keeping them until I start seeing March 21st. Because the way it is in the South, you can have 70-degree weather one day and an ice storm the next. I'm keeping those 10 bales for the ice storm. If I don't have it, then I'm just going to give it to the cows and let them have a party.
Well, there's no hay in it. And there's a guy in Anderson who sell them $75 a pack.
It was probably my uncle, William Martin. That's my uncle. Martin Hay Company. Yep.
We had a hospital down there.
No, I think that's in Martinville. He's from Townville. He's from Martin's in Townville. All right, y'all finished yet? Miss Sheik, you finished? Okay, if she's not finished, I'm gonna give y'all some more time. Yeah, because she don't pay attention to me. She works. All right, it takes you an hour and a half to do this problem, then chances are you're going to fail the test. Just thought I'd tell you that. That's interesting. All right, with negative x squared plus 12, this is the vertical what? vertical shift, that's right, class. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're probably talking about a vertex, x squared plus 12, be something like this. And then x squared minus 6, vertical shift of 6 down. 1, 2, 3, 4, 5, 6. So we're talking about the area. Now, Ms. Sheep, the other day you asked a question about being symmetrical on the problem that had the line going this way and it's not symmetrical. Is this one symmetrical? Yes. So you can do 2 times 0 to wherever and do it because it's symmetrical. But see, the line was running through here last time, and this side is not symmetrical to this side, so you have to go from -2 to 0 and 0 to Yeah, you could.
I was just wondering, like, there's other just saying,
Yes, if it is symmetrical on both sides. But that problem, it wasn't because the line was going at a 45 degree angle. That's why. Well, one function was symmetrical, but the other one wasn't. These two are both symmetrical. So, negative x cubed plus 12 is equal to x squared minus 6. And I'm going to take this x squared across the river. It becomes 2x squared plus 6 is 18. Divide by 2. Divide by 2. X squared is equal to 9. X is equal to positive and negative 1. Okay, now this is a type question I like to give on tests because it doesn't try to trick you. So -3 and positive. So you could do this 2 ways. You could set it up and go and you could go from -3 to 0. So 0 to -3 of, let's see, that'd be minus x squared plus 12 minus x squared minus 6 dx, and then add from 0 to 3, same thing, dx. Whatever. Or, since this side is symmetrical to this side, and there's no funny business going on with a line going through the middle or anything, this is symmetrical. In other words, they're the mirror what? They're the mirror image of each other. So you could do 2 and just keep it positive and go from 0 to 3 of negative x squared plus 12 minus x squared minus 6.
you put 2 there, we back it up to the.
What?
Or we had, back it up to.
No, I'm saying these 2 areas.
Oh, I see. Okay.
This area and this area is the same. So instead of doing all this, instead of writing everything out from -3 to 0 and from 0 to 3, I'm saying I'm not going to do that. I'm just going to do 2 times this side
Okay.
because it's symmetrical, but it has to be symmetrical. So at that point, go ahead and do it.
Yeah,
I think that's right. Volume can't be zero, it'd be non-existent. I've done come to the conclusion that I cannot text on a phone very well. I can hit every letter with my thumbs except the letter I'm supposed to hit. And we all know whose fault it is. All right, so let's see if we get zero. So, 2 times 0 to 3, and I'm going to clean this up a little bit. Negative x squared plus 12 minus x squared plus 6 dx. And that's going to give me 2, 0, 3, negative 2x squared plus 12 plus 6 is plus what? 18. Take the derivative of that, and we're going to get 2 brackets. It'll be negative 2x to the third over 3 plus 18x evaluated at 0 and 3. Now notice I have the 2 outside the brackets. Is that important? Yes, very important. Okay, and that's going to give us, I'll do 0 for y'all. 0 comes out to be 0. So now we just got to worry about the 3. 3 cubed is what? 27? 27 times 2 is 54. 54 over 3. Negative 54 over 3. Plus 18 times 3, which is 48. No, 18 times 3 is 64. No, 54. 54 plus 54, which we don't need 54. We need 54. We need it to be in terms of 3, so that'd be 162 over 3. Somebody help me out. What's 3 times 54? Thank you. And what is negative 54 plus 162? I don't know. I'm asking y'all.
54 plus 162.
108. So that'd be 2 times 108 over 3. Y'all check the math. Check. Make sure. And then 2 times 108
Dang old 216 over 3. Dang old 72. Y'all check me. 72 square units. Question. This is a good test question. I like to use these type test questions because it's easy for you to graph, it's easy for you to get the intersections, and it's easy for you to calculate. So these are the type questions I like to pull from. And again, if you want these in the book, on page 427, which is 6.1, whatever book you're using, I would say maybe 5 through 28. Okay? Now, today we're going to move into the handy-dandy world of volumes. Now, what's the difference between volumes and area? Area is 2-dimensional. Volume is what? 3-dimensional. So we're going to add another thing to it, which is called depth. Now, of course, I can't use but 20 minutes because our IT division says that they can't find GeoSketchpad. The company that makes GeoSketchpad, they can't find them. I guess they just disappeared. You know, but this DVD, the lady that makes it, Miss Audrey Weeks, she says that GeoSketchpad is running just as fine as we've never changed, but our IT division says that they disappeared. So I can't get a license on this computer, so I only get to use it for 20 minutes. Training! Y'all start to see a pattern? Y'all start to see a pattern here at Tri-County Tech? Anything that have to do with IT? Shut up, people. No. We hire people that's been in the area for hundreds of years. Does that make sense? See you, Mr. Edwards? Edwards, right? Okay. Already got you down. Okay, let's pull up switch. Just add it. Yep. Just disappeared. Company just disappeared. But their stuff is still on the internet. But they disappeared. Can't find them. Open. And the problem is that I can't, it's hard for me to find, it's hard for me to work on it when I don't have but 20 minutes of GeoSketchpad to work from. So I'm having to do the best I can. And here's our volumes. And I'm just doing this just to show you a little bit about volume. See, there's my 20-minute, I got a 20-minute preview that I can use. And there's a disc.
Why can't you guys just hit just?
Well, when you do that, they say it goes to a page that's not, and that's what they said. They haven't tried to call the company. They haven't tried to do anything. They just went to a page and it said does not exist. So now they tell me, and what am I supposed to do? I'm supposed to say, darn, the company went out of business. Oh, well. That's what I'm supposed to do, but I'm not. But anyway, that's the disc right there. Everybody see the disc? There's the disc. And what? Shh. No. No. Email that to me. So I'm going to email it. I'm not in the department yet. Okay. And there is a shell. Now, why is a disc a washer and a disc a shell? I mean, why is disc and washers the same? Because you can move this in. Of course, I can't move it in right now. It won't let me. But if you move the radius to 0, the disc, the washer, turns into a what?
There's only other one word over here. The washer turns into a what? A disc. The difference between a disc and a washer is the difference between a Danish and a donut. What's the difference between a Danish and a donut? One has a hole, the other one doesn't. Yeah, some of y'all are just now making that. Yeah, play football. But that's the difference. Now, a shell is just what a shell is. And I like to tell students to just kind of mark that out and just put cylinder or a tank, because that's basically what you're talking about. Now, if you move the radius in, you've got a tank. If you move the radius out, you've got basically another disc, another washer, but it's deeper, okay? So, of course, match these up with your dang old formulas right here. Now, when you're going around the x-axis, blah, blah, blah. When you're going around the y-axis, blah, blah, blah. Now, when we're going to get into a shell here in just a minute. And I didn't have time to run that one off. Let me, there's one in here that I always use, and it's the, in here, cylindrical shells. It's on page 441, and I'm going to see if I can pull one up right quick. This could be one right here. Let's see, revolve. Okay, no, I want to put the axis. See, it won't let me move anything. It's a conspiracy. Get out of that. Spin region. Right. There's a shell right there. But there's a shell right there. Stop. Okay? So, thank you, dang old Colosseum. Dang old Roman Colosseum. Unless you're shell. Now, a lot of you are saying, well, why is he making all these? You've got to figure out a way to learn the difference between the three things. Between the washer, between the disc, and between the shell. A shell is usually something in the form of a tank. All right? It's some kind of form of a tank. Think of a football. All right? If I give you this, and you revolve around the x-axis, then your volume is going to be a what? It's going to be a football. Okay? You've got to think, it's kind of like when if any of you ever taken a 3D, or not 3D, a mechanical drawing class or a CAD class, you have to think in terms of three what? Dimensions. And if you suck at thinking in terms of three dimensions, then you need some extra practice by going to Google and start doing some 3D pictures, some Wolfram 3D or whatever. You've got to start thinking about what it looks like, all right? Because if you go into mechanical drawing or CAD drawing and you've got a two-dimensional eyesight, you're going to fail that class because you have to think in terms of three dimensions. And when you're talking about three dimensions, if I just gave you this, I can't reset it, can I? Yeah. If I gave you this right here and said, what would this look like? Well, some of y'all would say a base. Okay, you're revolving around this. Okay, that's what turns it into a shell. If I did it right here, it would be a disc. If I revolved it around the x-axis, it would be a disc. And then it would look like a base or a bowl. Now, a lot of you are saying, I don't know what he's talking about.
Why could it be a disc and doing a hole?
That would be a washer.
Oh.
Think of a disc as a quarter, okay? We good? Now, if you don't know what a washer looks like, that's your parents' fault, and you need to talk to them, okay? Go to the junk drawer of your house. Ask your mama where the junk drawer is. If you don't have a junk drawer, then that says a lot too, okay? Every house has a junk drawer. It's usually the potholder drawer in the kitchen, or it's a drawer in the closet. But every screw and every washer that's been in that house that you have extras, what do you do with it? You throw it in that junk drawer. And there might be a couple of screwdrivers, a tape measure, a pair of pliers in there too. Reach in there and find you a metal disc that has a hole in it. And that's called a washer. Now, if you want to find a metal disc without a washer, just a disc, that's a quarter or a dime. Now, if I could move this, which I can't, can I? Well, I want to revolve around the x-axis. Let's see, it won't let me do that. But if I revolved around the x-axis, I would have a cup. But since I'm not revolving around the x-axis, I'm revolving around the y-axis, that disc now becomes a what? A shell. And now, instead of a vase looking through that dimension, you have what? Dang old Coliseum. See if I can stop it. Boop. There's your Coliseum. They call it the Coliseum in Rome, right? We studied that in art and architecture. Love that class. And it's amazing how they built the Coliseum. I mean, it's really amazing. Because everything is based on what? An ark. Everything in the Coliseum is based on an ark. It's what's holding up the whole thing. And versus post and lintel. With post and lintel is two posts and a bar going across. So, how do you deal with a shell? Well, let's look and see. With a shell, let's go to the handy dandy. Where's my WebAssign? I guess I lost it. With WebAssign, I'll pull up the book. Just give me a second. I thought I had it pulled up. And I'm in 6.3. If you've got a book, which probably many of you have. Because I told you not to buy one, didn't I? You were told me not to buy a book. You never did say that. I never did say that. They all go to the bookstore, and I get in trouble every year. Are you telling your students not to buy a book? Yep. Told them not to buy one. Told them they could just learn it by heart. Where do y'all get some of this stuff that y'all tell my boss? I think it's chapter 6, isn't it? There we go. 6.3. Volumes by cylindrical shells. And there we go. Now again, if you rotate this, what would you get? And I'm going to blow this up because I want you to see, test your visualization. If I was to just do a disc around the x-axis on this guy, what would it look like? Spin top, good. One of those spin tops. Have you ever seen one of those old toys? Of course, they probably tear your hand off, but I have one. And you do like this, and it keeps going faster and faster and faster. Have you ever seen one of those? It's an old metal type thing that you can cut your arm with and probably kill yourself. But you sit there and you do like this over and over and over, and it gets faster and faster, and you can just let it go, and it's just a big top. Well, that's what it would look like. But if you did this same thing with a shell, what would it look like? It would look like some crazy bowl. It would look like a bowl, wouldn't it? Because you're revolving it around the y-axis, you'd have an open area here, but you'd have a big old, kind of like a berm. You know what a berm is? A berm is like a big, like this. It would be like this. I wish I could do it on my, let's see if I doubt I could do it on here. Let's see. Well, I don't know if I can do this or not because no. Mm, no, it's our Coliseum again. I was going to show you what it would look like. They don't have one in here, so just forget it. They don't exist, remember? But that's what a shell gives us also. You're revolving around the x-axis. Now, you need to remember that volume is equal to 2 pi RH. You need to remember that. And pi is going to be involved in all of these because you're revolving. So remember that. And then on the next page, they should be showing you. There we go. The volume in the solid figure obtained by rotating around the y-axis, write this down, is V is equal to 2 pi x f of x dx. I am so leaving here and getting me a Sprite after this class is over, or a Gatorade or something. 2 pi x f of x dx. Now you might want to write that down on here. Duh. Your sheet that I gave you, the volume of a solid around the y-axis is 2 pi x f of x dx.
The other formula was for the x-axis, or
I'm sorry, what?
the other formula was for the x-axis? The 2 pi r.
That's just what's used in all of these somehow, some form, because of the cylindrical shape. I just told you that. This is there's your 2 pi r right there. 2 pi r is right here, 2 pi x. Because when you're talking about this, let me show you a little trick learned in the war. When you're talking about, that's a joke. See the football? No matter where you're going, this guy right here is going to be a distance, right? Distance here, distance all the way here, right? That is x, right? Well, if you are revolving around the y-axis, that x, instead of a disk around the x-axis, it becomes a what? What is that? What's this? On a circle. This is a circle. What's this? Starts with an R. Radius. So now your x becomes what? Your radius. Because you're revolving around the what? The y-axis. Now, when it's around the x-axis, x is x. But when it's around the y-axis, x is r. So 2 pi r is now 2 pi what? Hold on. Let me make the connection here. 2 pi r is now 2 pi x. Now what is f of x? Well, let's go back to our handy-dandy drawing. That really sucks. Okay? The height of this football is what? The actual what? The actual equation or the function. So to find the volume from 0 to whatever, the antiderivative of 2 pi r h. Well, we've done decided that the r is equal to what? And what is h equal to? You see it? What is it? 2 pi x and then f of x. So if you want to do anything, thank you. Appreciate it. Now we're charged for that. Take your highlighter and highlight that f of x because that's your actual function. And then take another highlighter, green, and highlight that x right there
And that's your distance from the origin to your radius, or your radius. Now the reason I'm using the book here is because I can't draw worth of crap. At least I'll tell you that right up front. And here's a prime example. And they're showing you exactly what I just showed you. But it's drawing it out a little bit. See, there's our x. Our x has now become our radius. And our f of x is equal to the height. And a to b is going to be 0 to whatever. Okay? And in this case, 0 to 2. Next page. Now, when it really gets tricky is when they start giving you crazy stuff like this. Okay? You're talking about something that looks like a vase, but the sides are actually what? Different. So I don't even know how to explain this one. All right? But the shape is like a V, but on the outside you've got different widths of it's like a clay pot or a clay vase. Where a vase would be just straight like this. This vase is thin on the bottom of the sides, and then it opens up thicker with clay, and then it closes up thinner. So you've got a weird looking vase, basically. And that's what you got right here. Now, the two functions involved are y is equal to x, which is this 45-degree line going this way, and y is equal to x squared. Now, what have you got to find there? That's called the area between two what? The area between two curves. Da-da-da. You're going to have that up here. Then you have the radius. The radius is going to be this right here, which is going to be these two functions. So you've got 2 pi x, and then the radius, the height, is the area between two curves, x minus x squared. Now, it's very important that you write that down. Okay, so if you want to, you can write this down and draw some kind of a picture, or you can, example 2 on page 452, because it's hard for me to draw this, all right? And I've only got 20 minutes of GeoSketchpad because GeoSketchpad disappeared. The whole company disappeared. So, you know, when you're working in troubled times like that, you have to depend on the book a little bit. Thank you for that email. Did you send it to me? It's called, they don't want to what? They don't want to fool with it. So if they tell the stupid teacher and the stupid department head that the company disappeared, the stupid teacher and the stupid department head is supposed to what? Believe them. Oh, they call it dynamic geometry now? Did it say GeoSketchpad? It did. I'm looking at it. Yeah, that's it. But why is it under dynamic geometry? Well, who knows? I'm going to say, from a calc student, they say that it hasn't disappeared. How dare y'all question the authority of the great Oz. I'm sorry, IT. Logical?
Yeah, it would be nice. Now, if you see what they're doing, they're going from 0 to 1. Now, most of the time, they're going to tell you, or you're going to see where if you set this point right here, and I hate to go back and forth. Remember, where are you revolving around? The y-axis. So you got to have a stopping point up in here. You got to find this point right there, because that's where they what? Intersect. And of course, it'd be nice if I could get a pen here. Yeah. So x is equal to x squared, and x squared minus x is equal to 0, and 0 is equal to x, and x minus 1. So it crosses at 0 and what? 1. Well, there's 0, so this must be 1, and if you plug in 1, you should get 0. Yeah, so that's 1 right there. So it's going 1 to 1. Yeah, the 45-degree angle is 1 to 1, so it'd be 1 to 1. So that's where they get the 0 to 1. Now remember, this is the part of calculus where you actually have to use your visual and your brain. And I hate to say it like that, like we haven't been using it. But if you look at a problem and you say, golly, that's going to look like football, and it's not going to look like a football, it's going to look like an inverted vase, then how are you able to do the problem if you think it's going to look like football? You see what I'm saying? You've got to look at the problem, and you've got to pull up whatever you need to pull up on your computer, on your phone, on whatever, to see what the thing looks like. Because if you don't know what it looks like, you don't know what 0 to 1. You don't know where you're going to be revolving. You've got to draw a picture of it. You've got to get a mental picture of it, a 3D picture of it. Because if you're still looking at the football, you not only miss the train, you miss the boat. Yes?
If we didn't have that figure that we just looked at the example, how long would you want it rotates around the y-axis?
They will tell you in the problem. Yes, and the shell. Whenever you're talking about a shell, usually it's around the y-axis. Okay? Because around the x-axis, it would be a disc or a what? Washer. Okay? Now, that's a good problem for you to look at, to put down in your notebook as an example. We're going to call it a day today, because I want you to let the area between two curves, I want you to get that down, and then you can apply that area between two curves. Remember, in the volume, the area between two curves is now going to be the what? Not the radius. The x is the radius. It's the what? The height. Dang old, looking at right there. See that? The area here is going to be the height. Now, how is that going to play into work? It's going to play like 99% into work, because you're going to see when we get there. Okay, I'm going to shut up. All right, I'm getting excited. How about people at home? You still with us, or y'all asleep?
We're asleep.
I figured y'all were all asleep. That's, you can only do so much when you're in bed, and you kind of. Let me get y'all pulled up right quick. Y'all still with us? Hey, they are. Well, no, there's only one that says 2. Miss Peer. Okay,
Yeah.
what turned their the dog must have turned it off. Yep, there it goes. Turned it on again. Okay, y'all have a good day. I'm gonna turn it off now, and I'll see y'all whenever I see y'all. Okay.
All right.
All right.